let's use the SUN project materials to see how this process happens. In particular, we're going to focus on the electron transport chain as electrons move from a carbon compound to oxygen, resulting in production of ATP. So, the first thing that happens is NAD plus picks up 2 electrons and a proton from this carbon compound and becomes NADH, and it brings those electrons to the first pump. That causes this pump to pump protons into the intermembrane space, so the space between the inner balloon or inner membrane and the outer membrane. Next, quinone picks up electrons and it picks up protons and carries them to the next pump. That, as electrons move across that pump, it causes that pump to pump protons into the intermembrane space. Now, I'm not counting exactly how many protons are pumped, but the idea is that as electrons move across the pump, it causes the pump to pump protons into the intermembrane space. Next, cytochrome C picks up electrons one at a time and carries them to the last pump. All of these are random movements, random interactions. There's nothing purposeful about any of these interactions. And as cytochrome C carries electrons, and as they move across this pump on their way to oxygen, which is bound on this pump also pumps protons into the intermembrane space. Now we've concentrated protons between the inner membrane and the outer membrane. And because they are concentrated, and the only door through the inner membrane you can imagine is a wall. They're not going to pass through that membrane. The only door that's open is the ATP synthase. And as they move through the ATP synthase, they cause its rotor and central shaft to turn, causes these alpha-beta subunits to open, ADP and phosphate can bind, and then as the alpha-beta subunits close and open again, voila, ATP is made. Now, we're not finished with our story here, because as electrons were stripped off of this carbon compound, CO2 goes off, and so one of the products made from cellular respiration is carbon dioxide. Another product that's made is, as electrons move across this process, I'm going to short circuit it here, and move all the way to oxygen, water is made. So here you can see oxygen, 2 electrons plus 2 protons, because an electron and proton makes a hydrogen atom. This is hydrogen, hydrogen, oxygen, H2O. So 2 of the products made as electrons move from the carbon compound to oxygen are water and carbon dioxide. But the important thing in terms of energy transfer is that at least some of the energy that was released as electrons move is stored in ATP. Much of the information about the process of cellular respiration, or at least the electron transport chain that's described here, can be seen in the SUN Mitochondrion ebook. If you go on the SUN web pages, you will see a painting by David Goodsell that shows you the molecular architecture of the mitochondrion, and that is positioned near a diagram of the tray. And you can play animations, you can explore the different components of the mitochondrion and explore this process in much more detail.